Okay, so we're going to start off probability looking at mutually exclusive events. And I'm just going to give you quickly the definition for a mutually exclusive event. Okay, it's a probability event in which the outcomes are disjointed, which means that they cannot occur at the same time. Okay, sorry for my very bad handwriting there. Okay, so they cannot occur at the same time. And the scenario I'm going to give you to start off with is, say we have a deck of cards. Okay, in our deck of cards, okay, there's 52 cards, 4 suits, hearts, clubs, spades, and diamonds. Okay, so as per normal. So our first scenario is that we've got our deck of cards and we're looking at picking out a heart. Well, from our deck of 52, there's 13 hearts in a deck. Okay, and we can and our options, if we're looking at if our event is picking out a heart, we can pick out a heart, or we could pick out a not heart, and our probability for picking out a heart would be 13 out of 52. Okay, and our probability of picking out a not heart then would be 39 out of 52. Okay, and so we can see here though that picking out a heart and picking out a not heart are two completely separate events. Okay, they're completely disjointed. So this would be what we would call a mutually exclusive event. Now, a non-mutually exclusive event is one in which there is an overlap in the outcomes. So now we're going to take our deck of cards again, but we're going to look at the probability of picking out a heart and a king. Okay, and this is going to be our scenario. So we're going to look at this. So we still have a circle for hearts. Okay, this is our heart circle here. And we know that there's 13 hearts altogether. And we're going to look at and we also know that there are 4 kings. However, there is one card which is both a heart and a king. So I'm just going to change this up a little bit because we now have one which is going to go into both circles. So I'm going to make these circles now overlapping. Okay, there's one that's a heart and a king, which means that my heart circle goes down to 12. Okay, and my king circle goes down to 3. Okay, and there's one in the middle, which makes that up to 13 and to 4 on that side. Okay, so this one would be a non-mutually exclusive event because there is a situation in which our events overlap. Okay, they're not disjointed, they're connected. Okay, so we want to look at each of these events and decide whether they're mutually exclusive or not. So the first one is a spinner has an equal chance of landing on each of its 8 numbered regions. After spinning, it lands in region 3 or in 6. So in this case, this would be a mutually exclusive event because the spinner lands in either region, 1, 2, 3, 4, 5, 6, 7, 8. But there's no overlap. You don't have any event which is going to be joined with another event. Okay, they're each discrete possible things that would happen. Okay, the second one, a bag contains 6 yellow jerseys labeled numbered 1 to 6. The bag also contains 4 purple jerseys numbered 1 to 4. You randomly pick a jersey. It is purple or has a number greater than 5. Okay, now this case, this would be not mutually exclusive because you're looking at picking a jersey and it's purple or has a number greater than 5. Okay, so that means that you've got at least one jersey which is yellow and greater than 5, and you've also got purple ones as well. So you've got, if you imagine your Venn diagram, okay, here would be your yellow. There's here you would have, greater than 5, and this would be purple, and you would have overlap between that where you've both got it, one that's greater than 5 and is purple. Okay. The next one, a magazine contains 12 pages. You open it to a random page. The page number is 10 or 8. Again, this one, you have no overlap with this one. So this one is mutually exclusive because there's no overlap between the magazine pages. Okay, it's got 12 pages. Page number is either 8 or it's 10. There's no kind of situation where you would have it being both or being dependent on the other. Okay, last one. A box of chocolates contains 6 milk chocolates. I'm just going to write this down before I forget. So 6 milk, 4 dark. 2 of the milk chocolate have 2 of the milk chocolates and 3 of the dark. So 2 have peanuts and 3 have peanuts. Okay, you randomly select and eat a chocolate. It is a milk chocolate or it has no peanuts inside. So again, in this case, this would be not a mutually exclusive event because you're combining the outcomes of where you've got milk chocolate and there's peanuts inside and where you've got dark chocolate and there's peanuts inside. And then also just the fact that it's milk chocolate initially. Okay, so again, in this case, you would have your Venn diagram would look like this one. So we've got milk chocolate and, sorry, I think I said peanuts inside. It's no peanuts inside, so no peanuts there. And again, just when you're doing probabilities, be really careful that if you've got an event with a dash, that just means not that event. Okay, so for example, if you're picking out, if you've got, what's a good example? So if you're looking at whether it rains, the probability of it raining on any day, okay, we would write the probability of it not raining as raining with a dash. Okay, so we say this is not peanuts. So there's only one chocolate which is neither milk nor has peanuts, and that's that one dark one. And then there's 9 which is milk or it has no peanuts. And then there's none which is neither milk nor peanuts. But because again we've got that overlapping condition, that means that that's not a mutually exclusive event. Okay, and drawing the Venn diagrams does really help, I think, to organise what you're thinking about. Alrighty, have a look at the worksheet and see how you go. Okay, cool, bye.